Okay, so 8.4 notes, inverse trig functions is our goal for today. It's going to be, 8.3 was to find a missing side of a right triangle, and today it's going to be to find a missing angle of a right triangle. Now remember, SOHCAHTOA, which is our big idea in 8.3 and 8.4, which doesn't mean anything if you can't spell it, so you got to make sure you know how to spell it, SOHCAHTOA. This only works with right triangles because right triangles have to have a right angle, which then give us a hypotenuse. A non-right triangle does not have a hypotenuse, so you can't label an OA and H, opposite, adjacent, and a hypotenuse, so you can't use this idea of SOHCAHTOA on non-right triangles. That's the big thing, that I really wanted to stress with you guys, okay? So inverse trig functions and the notation. So if we write the inverse of sine, the way that it's written on your calculator, it almost looks like it's to a negative first exponent. So it looks like this, the inverse of a cosine, same idea, and there's theta. And the inverse of tangent, also the same idea. And I guess I really didn't need to put those thetas in parentheses. It doesn't matter if you have them there or not. Okay. But those are what the inverse look like. So on your calculator, you're actually going to hit the second button and sine in order to get to this inverse sine button. Okay. For inverse of cosine, you're going to actually hit the second and then the cosine button. You'll notice right above it, it has what looks like this, cosine inverse. So to use that, you have to hit that second button. So how do I figure out the angle measure if I'm giving a trig ratio? So this would be our setup this time. So we actually don't have the angle this time, but instead we have the ratio. Before it was something within the ratio that we were missing that we had to solve for. This time though, it's A. Now, like I said in 8.3, sine and A go together, or sine and the angle go together. They're not separate numbers. You can't just divide by sine and be left with A. It doesn't work like that because sine means nothing if it doesn't have an angle with it. So to undo it, you actually have to take the inverse of both sides. So what we do is we take the sine inverse of this, and you kind of have to write it underneath or above because it has to be written on the left, okay? So sine inverse of sine of A and sine inverse of this 13 over 15. Now on the left side, what happens are your sine and your sine inverse cancel, and you're left with A. And on the right side, we're going to type that exactly into our calculator the way that we see it. Make sure to use those parentheses because if you don't, it's not going to work. So sine inverse, so second sine button, and then type in 13 divided by 15 and close that parenthesis. Okay? And it should come out that A is going to be approximately 60.1 degrees. Okay. We're going to do something very similar with example 2, but this time, because you started with cosine, we have to use a cosine inverse in order to undo cosine. So again, once you do the cosine inverse, your cosines go away. You're going to be left with B is approximately, and this one you didn't even have to type in. That is to a negative 1 up there. You don't even have to type in a fraction. You're just typing in second cosine 0.7656. And this one tells us that B is approximately, now B is an angle measure, so it's approximately 40.9 degrees. And then C, or example 3, we're using tan. So why don't you guys try this one on your own based on what we did in examples 1 and 2. Hit the pause button and see if you can figure out what the measure of angle C is. And actually, the way that we should be writing these are the measure of angle. So let's see if we can find what the measure of angle C is. So go ahead and do that now. So when I did this, I used tan inverse on both sides, and I got that the measure of angle C was approximately 49.1 degrees. Okay, so that's what our setups would look like, and then we solved it. But let's actually figure out how do we do those setups then. So for example number 4, we're going to find the missing angle measure. So we're given this angle, and when we're given the angle, we go from this angle and we have to label sides OA and H. Okay, now also remember, we're going to need that word SOHCAHTOA right in our back pocket. So let's write that right up there. I always just write it at the top of your page. That way you have it as a reference. Okay, so from this angle, we have, this is our right angle here. It should have been labeled. I'm sorry that it's not. This one here should be labeled also. I'll put that in black because that was supposed to be a given. Okay, so from our right angle, across from that, we have the hypotenuse. Across from the x, we have our opposite, which leads this side to be the adjacent. The adjacent's not labeled as anything, so we really don't care about the adjacent on this one. So which of our trig functions has an O and an H? Sine. Okay, sine has O and H. So I'm going to set this up, and it's going to be sine, what's the angle? X. We don't know what that angle is. That's what we're actually looking for this time. So sine of x is O, which is 15, over H, which is 20. So now what we're going to do is we are going to take the inverse of sine on both sides. Now notice what I wrote in blue is exactly what was given to us on these first three examples. It was written just like that. So that's how we solved it. We took the inverse of sine on both sides, and what happens is your sines go away, you're left with x. So the measure of angle x is approximately, when we type in the right side in our calculator, the inverse of sine, so second sine, make sure 15 divided by 20 is in parentheses. It should come out to be about 48.6 degrees. Okay. Now, number 5 is a little bit different because it actually gives you all three sides, and it's actually asking for two different angle measures. So there's a couple ways you can go about this. You can find one of those angle measures, and then we know that the sum of the three angles has to be 180. So you can figure out the other angle based on that, or you can use this trig idea to figure out both A and B, and then make sure that A, B, and that 90-degree angle all add to 180, and that's kind of your way to double check it. Okay, so this one from A, I'm going to do this in two different colors. Across from the right angle, this is going to be your H. That's always the same. Across from A, though, is our opposite, and across from, or next to A, is our adjacent. So there's our O, A, and H. If I am looking at angle B, this is still my hypotenuse, but this becomes my opposite, and this becomes my adjacent. So be careful because it depends on which angle you're going from. So if I want to do angle A first, I'm going to be using the yellow. Okay, let me actually switch this to green so they're quite a bit different versus the yellow and the orange. There we go. All right, so if I am using the yellow, it doesn't matter which trig function you use for finding A because we actually have all three of them. So pick your favorite one. Maybe it's sine. So you would do sine of A is equal to, sine is O over H. So I'm going to use O, the yellow O is 4, over the yellow H is 5. From there, I can solve by taking the inverse of sine on both sides, and I'm left with the measure of angle A is approximately, it was about 53 degrees when I typed that in. So second sine, 4 divided by 5 inside parentheses, you're going to get sine, the measure of angle A is about 53 degrees. Okay. Now I'm going to use green, and I'm going to set up for B. Okay. Maybe you want to use cosine now. Maybe you want to use cosine of B. It doesn't matter which trig function you use because you have all O, A, and H. It gave us all three sides of the triangle. And if it didn't give us all three sides, you could always use Pythagorean theorem to find the third side of a right triangle. That's what we learned in 8.1. Okay, so cosine of B, cosine is A over H, so we want A on top. The green A is 4, and H is going to be 5. It almost looks very similar to what we had over here, but we have a different trig function, which does matter. Okay, so we're going to use cosine inverse on both sides, and what we're left with is the measure of angle B is approximately, type into your calculator, second cosine 4/5, and we're going to get approximately 37 degrees. Now this is where I said that if you want to double check things, make sure that one's 53, this one's 37. Does it make sense? 53, 37, and 90, does that make 180 degree? And it does, so you're good, okay? If I was asking you to round to the nearest hundredth or whatever, sometimes you're gonna be very, very close. You would be at like 179.99 or 0.9 or 0.89 or something like that, just depending on how we round it. But if you're very close, 180.1, then it is okay. It's just a matter of how we had to round. So, but as long as we're really close to that 180, that's where that comes from. So we checked it, we're good. Other than that, that's all we have for the notes. If you look at your assignment 1 through 6, the setup is already done. You're just solving to find the angle measure. So find the number 1, find the measure of angle A, all the way down through number 6, find the measure of angle C. Once you get through to 7, numbers 7 through 26, use the angle that they labeled and figure out which trig function to use. Show me your setup, show me your solving, and find the measure of those angles. Okay? And if you have any questions, let me know.